Today we're going to be looking at a lot of the base data that's used within Vissim, which is going to be really used to kind of build up all of the models. So this is going to include information about the vehicles themselves. So we're going to go over vehicle types and vehicle classes, along with all of the data functions and distributions these vehicles are going to use. And then we're also going to cover all of the speed network objects in Vissim, along with vehicle compositions. So overall, FHWA has 13 different classifications for vehicles. So you'll see there are some passenger cars in there. There are some buses, heavy trucks, which are defined by a number of axles and trailer type. Vissim itself is going to use 6 general categories, so car, heavy goods vehicle, bus, tram, pedestrian, and bike. So those are going to be the general categories you'll see in Vissim. But each of these can be contain attributes that can be further refined, such as information about the vehicle model and dimensions themselves, as well as information about their acceleration and deceleration. So all of this information for the vehicle types is going to exist under that base data menu. And this is kind of going to be most of the area that we're going to be covering today. So if you click on base data up at the top of the Vissim window, you can then go down to vehicle types, which will open up a list at the bottom, which is going to display that data. And so within this list, you'll see here we have the number of those vehicle types, the name, as well as that category. And so this list itself is just going to contain some of those commonly used attributes, but you can double click on any of these rows or select this little pencil edit icon up at the top, and this will open up another window which will show all of the available attributes that you can edit. So within this vehicle type window, again, up at the top is where you can define that category. So again, you can define car, heavy vehicle, bus, etc. And so these vehicle categories are really going to specify mainly that basic behavior that these vehicles will have in traffic. So for example, the heavy vehicles are going to use some weight and power distributions that the regular car category will not. And then another example is like the tram category. Those will not be allowed to make any lane changes. So these just really kind of just define that basic behavior. Also within this window is where the vehicle model can be defined. And so this is actually a distribution, which we'll talk about a little bit later. But essentially, this is going to be a group of different vehicle models that are going to be contained within this vehicle type. And you'll see down here below, since this is a distribution, there's going to be a set length that each vehicle type will have. And so you can kind of see that range of the from and the to for both the length and the width for all of those included vehicle dimensions. And then down at the very bottom is where you can further define some distributions for any of the vehicle colors. And then on the next tab is where all of the functions and distributions associated with that vehicle type are kind of housed. So at the top is where you'll see both the maximum and desired acceleration and deceleration functions, which again we'll talk about in more detail a bit later. And then down at the bottom is where there's also the weight and power distributions. And again, these are just going to be used for those heavy trucks when you're modeling like those HGVs. And then the very bottom is where you can also define an occupancy distribution for any of the private cars that you're using or for transit. And then within the special tab is where you can define additional parameters for dynamic assignment. So all these items kind of at the top will be for dynamic assignment. And then down at the bottom is where you can further define some public transit parameters. So this would be information about the vehicle capacity and how the dwell times are going to be calculated for people boarding any of those transit vehicles. And then down at the very bottom is where you can also enter in if you had created an external DLL that kind of captures detailed vehicle emission data. you can load that in and use that to get additional emission information about this particular group of vehicle types. And then that final tab here is for the external driver model. So this is, again, where you can build up a custom DLL and load that in if you wanted to kind of build up your own driving behavior and driver model. All right, so that kind of covers the attributes associated with the vehicle types. And these vehicle types can then be grouped together within a vehicle class. So really, these vehicle classes are just a group of different vehicle types. So for example, if you have, maybe you have some vehicle types like the heavy vehicle, a van, bus, and then a single occupancy vehicle and a high occupancy vehicle. So these could be all your different vehicle types that you have. And then these can be further grouped together. So for example, maybe you have a car vehicle class that would contain both the single and high occupancy vehicles. And these vehicle classes are really going to be used throughout Vissim in a lot of like the network objects. So we'll talk a little bit later for the speed objects, but essentially these speeds in the network are going to be defined based on the vehicle classes. So again, these classes are really just a group of vehicle types, and these class definitions are going to be used basically everywhere in Vissim except for the vehicle composition definition. And we'll talk about that near the end of the presentation, but the vehicle compositions are actually just going to reference the individual vehicle types themselves. So other than vehicle composition, the vehicle types won't really be used anywhere else in the network. All right, and then so to access these vehicle classes, again, if you go to base data and then select vehicle classes, that will again open up that vehicle class window down in the bottom of the screen. And within this class window, this is where you can see all of the attributes. So the vehicle classes don't have any additional windows or editing windows or anything. So all of the data will just be stored directly in this window. So you can see here we've got, again, a number and a name for those vehicle classes. And then here's where there's going to be like a little drop down. You can select to choose all of the different vehicle types that are associated with that particular vehicle class. And also on the right-hand side, you'll see any of those vehicle types are going to be referenced within that child list itself. So you'll see if you had, for example, in this case, we just have one car vehicle type, which is referenced in the car vehicle class. But if you had additional vehicle types, those would show up over on that right-hand side within that child list. All right, so now that we've taken a look at both the vehicle types and vehicle classes, next we're going to take a look at some of the more detailed data that these vehicles are going to use. So again, we're going to be looking in that base data menu. And within here, there's two separate sections. So one is for the functions, which will be used for like acceleration and deceleration for all the vehicles. And then the other section is for distributions, which is going to be used for the desired speed of the vehicles, also for any time distributions, or for the 2D, 3D vehicle models. So in order to account for a lot of the differences in vehicle properties, Vissim uses the acceleration and deceleration as a function as of the vehicle's current speed, rather than just kind of having a set or an individual like acceleration or deceleration value. So Vissim is going to default to the desired acceleration and deceleration values, but they will never exceed those maximum values that are set here. So those kind of max acceleration and deceleration will never be exceeded while those vehicles are in the network. And if you select any of these, again, that's going to open up a list down at the bottom, and then you can edit those lists to see those functions in more detail. And so for any of the acceleration and deceleration functions, The speed is going to be on the horizontal axis, and you can see up at the top, it's going to set that minimum to 0, and then you can define the maximum speed you want for that particular function. And then on the vertical axis, you'll see you'll either have the acceleration values or the deceleration values, depending on that function you're looking at. And then in the main window here is where that function itself kind of exists with all those data points. And so you'll see here along this kind of red dotted line, these are going to be the median acceleration values that are used. And then these are kind of bounded by these green lines that are shown on either side of that median. And so by default, a lot of these acceleration and deceleration functions are going to be built into Vissim for you. So you can kind of use these as a default and then kind of adjust as needed if you have a particular, a different type of vehicle or something that you want to include within your Vissim network. All right, and then so kind of moving on to this distribution section. So within Vissim, there's a lot of different options for using distributions. And some of the big ones that we're going to cover today are the desired speed distribution, which again is going to be for setting up the speed for vehicles on different types of roadway. And then we're also going to take a look at the time distribution as well, and then also the 2D, 3D model distribution, which can be set up within those vehicle types that we looked at earlier. All right, so the first one we're going to take a look at in more detail is those desired speed distributions. And so these are really going to be used to define that free flow speed along the roadway network. So it's really important to set up these distributions so that they'll represent, again, that free flow speed and not any sort of like congested condition speed or anything like that. So again, all of these distributions are going to be found in the base data menu. And then if you go down to distributions, you can select the desired speed option. And that's going to open up, again, another window down here in the bottom. And within this window, you can add additional distributions by clicking that plus button up at the top. And then you can also edit ones that already exist by clicking that pencil icon. So within these distributions, they have some data that's going to be shown again within that list. So you'll see here on the left-hand side is going to be the ID value for that distribution. And then on the right-hand side are the lower and upper bounds that are going to define the minimum and maximum values for that particular distribution. You'll also see here that there is a name for that distribution. And this is really just a label, which is just a text field, so you can really type in anything here. By default, these the Vissim networks are default to metric, so all of these labels are kind of entered in as kilometers per hour or meters per second. So you'll see these are still listed in metric, and we'll talk about that next too, about switching the base data to use imperial units. However, these names are really just a text field, so these will actually still show as kilometers per hour. So typically what we'll do is we'll go in after we've kind of updated to imperial units, and then we can further refine these distribution names and the data that's there. And then over on the right-hand side is where all of the data points are listed within the distributions themselves. So if you edit or add any new distributions, you'll see this window will show up where you can define, again, that minimum and maximum value that will be used within that distribution. And along the x-axis, this will represent the speed, and the y-axis will represent that percentile value. So for example, in this case, we've got our 75th percentile located at about 31 miles per hour. And again, all of these data points, which will show up as red dots, these will show up within that right-hand section of the window as well. So if you do need to further refine kind of these points, you can always come into this data point section and update these values within here as well. So again, real quick, just wanted to touch on that metric unit update. So if you do want to switch all the base data to be referencing imperial units, if you go back to that base data tab and then click on network settings, you can select the unit section within this window. And this will allow you to either update, you can just click all imperial to update everything, or you can change these drop downs over here to change those values. And again, these will update all of the data themselves, but again, you'll just have to go back and probably update the labels that are used within those desired speed distributions. All right, and then in order to add or move any data points within this distribution window, you can right-click along this line, and so that will drop in one of those red data points. And then in order to move those, you can just left-click on the data point itself and just kind of move it again to that particular percentile and speed value that you're looking to model. And then if you want to remove any of these data points, you can just click on one of them and either drag them to another data point, and that will kind of combine them and get rid of that extra one. Or you can also move them to either of the corners to the very edge, and that will also get rid of that extra data point for you too. And then we also wanted to mention that if you do have any sort of like free flow speed data, we can definitely help you set up kind of a specific data set that has that information contained within the desired speed distributions. So that's definitely something that we would be interested in helping with. So we can do this either by region or by area if it was urban or suburban, or even by speed limit if you have any of that data and kind of want to develop some of these distributions that can be used within Vissim. All right, so the next type of distribution that's commonly used is that time distribution. And so this is used for setting up transit dwell times, and also for if you had parking lots modeled in the network and wanted to set up the dwell times, the vehicles will be sitting within those parking spaces. And also you can use this to set up waiting times if vehicles are at a toll lane or at a border crossing. So again, if you go back to that base data menu and then go down to distributions, you can select time from that window. And that will open up again that time distribution down here in the bottom of the page. And so time distributions can be set up in one of two ways. These can either be set up as an empirical distribution, so very similar to the desired speed distributions, which have a min and max value and then have those data points kind of set up. Or these can be set up using a normal distribution, which will just use a standard deviation and a mean. And so in order to add any of these new ones, what you'll do is you'll just right-click in the white space of that kind of window on the left-hand side for the time distribution, and then you can go to Add, and then you can select whichever type of distribution you want. And then from there, again, for just those normal distributions, you can just enter in those values within these standard deviation and mean sections. All right, and then the final distribution that we want to cover today is for the 2D and 3D vehicle models. And so this is where you can define all of the different types of vehicle models that are going to be used within those vehicle types. So these distributions are kind of unique in that these use a relative share rather than an empirical or normal distribution. So basically, here's where you can set up those share values, and then Vissim is going to internally add up all of these to create a sum of all of these shares, and then it's going to calculate the relative share for each of these as a ratio of the individual share to the whole total share. So based on these kind of shares that are set up, these will be how those vehicles are going to be used within the network. And so if you click on any of these, all of these distributions kind of have all of these models will show up on the right-hand side in that child window. And all of these models can be either you can add new ones or you can edit the existing ones. And if you're editing any of these, you'll see this 2D, 3D model will show up over here on the right-hand side. And this is where you can load in the files as well. So you can load in files from SketchUp or from AutoCAD if you have some of those vehicle models that you want to specifically use. And then all of the information associated with these models will show up on the right-hand side. And so kind of really the most important section up here is going to be the dimensions that are shown up at the top. And so this is where you can see the vehicle length and width and height. And it's really going to be that length that's going to have the most impact in your models when you're running the simulation, because the length of the vehicle is going to be used for those vehicles to kind of take up space on the roadway. And so just kind of as a test so that we could see and just kind of show you how the length of those vehicles can really impact the simulation. So here was a quick test that we did with one using all F-150s versus using all Volkswagen Golfs. And so for both of these, we kind of set them up to have all the other settings the same. So we were using 1,000 vehicles entering the network per hour, and both were using 40 miles per hour kind of speed definition. And so at the very end of this link, you can see here we had a stop sign placed down. And you can see after about 330 seconds, there was about a 10% difference in the queues that were formed, again, just based on that vehicle space. So again, it's really important to make sure that you are using a relevant vehicle models within the network so that you can get accurate queuing data. And again, kind of similar to the speed distributions, if you do have any kind of Florida-specific vehicle model data set, we will be more than happy to help you kind of develop that and kind of create some different vehicle types and the vehicle models and get those all added along with the distributions that you can just kind of use as a base when you're starting to build up your networks. And again, this is something that we could do either by region or by area or kind of however you have any of that vehicle model data. And we do have some other vehicle models that you can download. So if you go to ptvtraffic.us/resources/v3d, this contains a list of different vehicle models you can download. And so we kind of have them built up by category, and then you can download those. And you can see the number of objects that are included in each of these packages. And then if you can select more to see more information about all of the different objects within this package, and like you can see information about those vehicle lengths that are so important. So feel free to visit this website and take a look and download these models that you can use within your Vissim networks. All right, so kind of moving away from that base data menu now, we're going to take a look at actually setting up the vehicle speeds within the network. So there are really two types of speed changes that can be modeled within Vissim. One is going to be a permanent speed change, kind of similar to like a speed limit, where you kind of have a point with a set speed. Or the other option is for just a temporary speed change that's going to be modeling like the turning speed, so if a vehicle is just making a turn, or for like a reduced speed for like a work zone, which will again be modeled using those reduced speed areas. So we kind of have these two different types. And again, for that permanent speed change, we'll be looking at using desired speed decisions, which are really just a point object. So again, you'll just place one of these objects. It'll just be at a single position within that link itself. And so all of these vehicles, when they are traveling, they're going to have their current speed set here. And then when a vehicle is approaching, and then when it finally touches that point object, that desired speed decision, that's when that vehicle is going to pick up that new target speed, and then it's going to start doing its acceleration or deceleration to reach that target speed. So again, for those point objects for the desired speed decision, the vehicles will not see them ahead of time. They're just going to come to that point, reach that point, and then start to do their acceleration or deceleration to reach that new target speed. And then kind of on the opposite side, we have those reduced speed areas, which again are just going to represent a temporary speed change. And so these, instead of just being a single point, are actually going to be an area object. And so these are going to have a length defined to them. And the big difference between these and desired speed decisions is that these reduced speed areas will be seen ahead of time. So as a vehicle is traveling along at its current speed, it's going to look ahead and see that reduced speed area. And it's going to decelerate in advance and make sure it matches that new target speed by the time the front of that vehicle is going to be on that reduced speed area. And then as it's traveling through that reduced speed area, it's going to maintain that reduced speed for the duration of that object. And then as soon as the front of the vehicle passes by the end of that reduced speed area, is then going to accelerate again and go back to its current target speed. So again, these are just two ways, again, where you can define either that permanent speed change using those desired speed decisions, or just a temporary speed change using those reduced speed areas. So when adding in the desired speed decisions, you'll just need to make sure you have that option selected over on the left-hand side within that network object toolbar. And then as long as you have that selected, you can right-click on one of the links that you want to add that decision to, and then you can go to Add New Desired Speed Decision. On the other side, you can also add these by just holding Control, and then you can use that right-click just to place those desired speed decisions along those desired links. And all of those desired speed decisions, when you add them either through the context menu or through the Control right-click, those will have a desired speed decision window that will open up. And so this is going to contain a list of all of those attributes associated with desired speed decisions. So up at the top, you have, again, those number and name that you can use. And then you can also see where that desired speed decision is located. So you'll see the link and the lane number, as well as the position along that link and lane. You can also define a time that these will kind of work for within the model. So if you wanted a desired speed decision to only work for a certain time within the simulation, you can kind of set up that from and until time as well. And then down in the very bottom is where you can set up what speed is actually going to be used by the vehicles in the network. And so again, this is where those vehicle class definitions kind of come in. So again, that vehicle class is a group of vehicle types. And so this is where you can set up the speed that will be assigned to each of those vehicles within that vehicle class. So if you right-click down here in the white space, this will allow you to add new line items where you can select that particular vehicle class and then its corresponding desired speed distribution. So again, this is going to reference those desired speed distribution lists that we kind of talked about earlier. So as long as you have those distributions set up ahead of time, once you're ready to add in your desired speed decisions, you can then select that particular distribution and assign it to its corresponding vehicle class in here. And so, of course, you can add as many vehicle classes as you want within here, and then you can set them up to have the different distributions or the same distributions if you want. Each one is kind of its own separate line item. And then for the reduced speed areas, these have their own section here underneath in the Network Objects toolbar. So in order to add those, you'll just want to make sure you have that selected first. And then again, you can either add this to a link through the context menu if you right-click on the link and go to Add New Reduced Speed Area. Or you can also press Control and then click and drag with the right click in order to add that reduced speed area. And again, these reduced speed areas do have a length associated with them and are not just a point object. So that's kind of why you hold the right click and then kind of drag in order to create that length. And so here again is kind of what those reduced speed areas look like. So they're kind of just a box with a desired length. And so again, when you add any of these reduced speed areas, those have another similar window to the desired speed decision. So again, these have the name and number. You can set up the position as well for that reduced speed area. And then you can also set the length. So this is kind of its unique attribute here where you can have the set length defined for that reduced speed area. And then again, down here at the bottom, this is where you can add in those vehicle classes along with their corresponding desired speed distribution. And then the one other attribute that the reduced speed areas have is this deceleration value over here on the right-hand side. And this value will be the maximum deceleration that the vehicles will use as they're decelerating when they approach that reduced speed area. So if you remember, the vehicles are going to be looking ahead at that reduced speed area, and they're going to see their kind of target reduced speed area speed, and they're going to decelerate in advance. So essentially this deceleration will kind of set how those vehicles are going to decelerate as they're approaching this particular reduced speed area. And so the lower this value is, basically the further away from the reduced speed area that vehicle will begin to reduce its speed. So this deceleration by default is set to 6.56, but you can adjust this if you did want the vehicles to start decelerating further upstream. All right, and then there is one other item we kind of wanted to bring up when either you're coding or reviewing a model. Just because Vissim is really flexible, you can really model things in a lot of different ways. And so one of those items is going to be the length of those reduced speed areas. So we really just wanted to show you kind of a quick example of using a kind of long reduced speed area for one of these turning movements versus using a smaller, shorter reduced speed area, and kind of just show you some of the differences that you might see. So here again, we have that longer reduced speed area here on the left-hand side. And so due to that length, you'll see that as vehicles are approaching that reduced speed area, they're going to look ahead and see what that speed is set to. And so the vehicles are going to basically start decelerating pretty early on, and in order to reach that speed by the time they reach that reduced speed area. So in this case, that reduced speed area kind of starts around B and then ends at D. So you'll see the vehicles will start to decelerate pretty early on, and then they're going to maintain that reduced speed for the entire length as the vehicle is traveling from B to D. And then as soon as it passes point D, that's when it's going to start to accelerate again and then go back to its desired speed. Versus if you do have a shorter reduced speed area, which right now is kind of just set on B, you'll see that the vehicles are going to maintain their desired speed much longer leading up to that reduced speed area. And then it's going to start decelerating again in order to meet the speed at C. And then it's going to hold that speed for a very short time. And then it's going to start accelerating again as soon as it passes point C, and then go back to its desired free flow speed. So these differences in geometry can really impact that vehicle behavior and really have a significant impact on the turning movement capacity. So it was just a note that we wanted to kind of bring up and point out that these differences can really impact the capacity. So just an item to keep in mind as you're modeling and also reviewing these models. All right, and then our final topic today is going to kind of move us out of that base data tab and just briefly go into the traffic tab. And so this item here is called vehicle compositions, and it's going to be that first item right underneath the traffic tab. And so vehicle compositions are going to be used by the vehicle input points, and this will kind of determine what types of vehicles are going to enter the network and in what proportions they're going to enter the network. So within the vehicle composition list, here you'll see, again, we've got our name and number over here on the left-hand side. And then all of the information contained within this composition is going to show up on the right-hand side within this child window. And so this is where you can set up, again, using those vehicle types. So this is really the only other place outside of vehicle classes where you'll see those vehicle types referenced directly. So in here is where you can select which types you want associated with that composition. And then you can also set up the desired speed distribution that's going to be used for the vehicles as they enter the network. And so this will kind of be their default speed until they hit one of those desired speed decisions in the network. And then you can also define, again, that relative flow over here on the right-hand side that will be used as the vehicles enter the network. And again, these vehicle compositions are going to be set within the vehicle inputs themselves. And that's going to be something we're going to cover in the coming week when we kind of talk about actually putting vehicles onto the network and seeing how those vehicles are added and routed. So this will be something just to keep in mind about how the vehicles are kind of placed onto the network. And again, this is going to be really the only other main place where you'll see those vehicle types referenced directly. All right, and so let me go over to our example here, because that kind of covers all of the base data information and those two speed objects. So here's where we have our Tallahassee model that we're kind of working off of. And this is going to be what we're going to be building up over the week. So you'll see this will kind of grow and kind of get all of these network objects added to it over time. So within this file here, if I go back to base data, we updated this a little bit to have some more American vehicle models. By default, a lot of these will just come with kind of the European vehicle models. So you'll see kind of all these at the beginning. These will be pretty small cars just because this is like the European vehicle model set that comes in default. And what's nice is when you open up the vehicle models, which again is under base data, you can see right off the bat what those different lengths are for each of these different vehicles. And so within this model, we actually imported some more American vehicle models that we can use moving forward. And so these kind of start at 1,000, and we just added a few here. And you can see kind of how those lengths differ and are kind of a bit larger than those default European ones. And then if you select any of these 2D, 3D models over here on the left, you can see more information about the file and about that particular vehicle model over here on the right-hand side. And if I go and edit one of these, this will bring up another window over here where you can see more information about that model itself. And so this is where you can load in other models. So if you click the little file icon here, this will allow you to load in files if you have something from SketchUp or from Autodesk, from 3ds Max or from AutoCAD. You can load in those files as well. And as soon as you load those, you'll be able to see the 3D model that got imported. And then you'll also see all of the information that was imported along with that model. So you'll see the dimensions again, the length, width, and the height. And then you can also see information about the different axle and joint positions, especially if you're modeling like a long train. You can kind of see how all of the cars are set up for that. All right, and then within the distributions tab, if I go back to 2D, 3D model, this is kind of where we gather up all of those different 2D, 3D models within a single distribution. So in here we have a car North American distribution that we added, along with a heavy vehicle North American distribution. So these will kind of reference some of those newer models that we added, and then have a different share for each of those over here on the left-hand side. And again, all of those will then be referenced within the vehicle types themselves. So in this model, if I go again to base data and vehicle types, this is where we have just kind of a base set. So we just have really one car vehicle type at the moment that references that particular 2D, 3D model distribution. And we just have one heavy goods vehicle distribution at the moment as well. And so a lot of these are just using the defaults aside from that vehicle model. So we've kind of got our car category set up, and then we're just using the default car acceleration and deceleration functions in here. And then kind of similarly, if I go to vehicle classes, most of these just have a one-to-one mapping. So in this case, we just have one car vehicle class that references that one car vehicle type. But again, if you did have a few different car vehicle types, you can click on this little drop-down that shows up within the vehicle classes, and you can just check the different vehicle types that you want to be included within that particular vehicle class. And again, you'll see more data for each of these over here in this child window. So this is where you can see each of those vehicle types kind of laid out, and you can just see a quick view of the data associated with them as well. All right, and then kind of moving on to the distribution section. So in here, right now we're just using that desired speed distribution for any of our desired speed objects and reduced speed area objects. So if I again go to base data, distributions, desired speed, we did make some updates to this because again, those kind of default settings have all these labels in kilometers per hour, and then the default units were set to metrics. So we did update that within the network settings option under base data. So you'll see here, if you take a look, at least all of these units have already been set to imperial. And then we went through and kind of added in and updated some of these and kind of changed that naming convention as well, so that these will show up as mile per hour. And again, you can edit any of these to see what that distribution looks like. So you can see kind of where those data points lie and the percentile value on the right-hand side, and then that speed value on the horizontal axis. And again, we've got our kind of min and max boundaries set up here at the top. And of course, if you add more data points, you can just control right-click to add those and kind of further shape this if you have additional data points that you're using for any of these free flow speed distributions. And of course, when you add those in, and if you click OK, you can see those points in more detail over here on the right-hand side. So if you did have a particular value, you can always come in here and update it as well once you kind of have those points set in place. All right, and so within this network, again, we will upload this file so that you can see this file and have all of these desired speed distributions and reduced speed areas in place. But you'll see all of the desired speed decisions if I select that from the Network Objects toolbar. Again, these are just going to be a point object, so these will just show up as a yellow line on the link itself. And so you can see we've got some placed in here already. And so we typically will place these at any location where vehicles are entering from another road or any place where there's going to be like a speed limit change along the roadway. And this again is where it is important just to make sure that your objects are kind of placed, if they're placed on the link, just to make sure they're not placed like before that connector start point. So that's where it's kind of important just to make sure your connector kind of ends near the beginning of the link and then you can place your desired speed decisions so that the vehicles can pick those up as they're traveling through the network. And then if we do want to add any desired speed decisions, so for example, we would probably want to add one to this roadway that's coming up to this divided highway. Again, you can just press Control and right-click to drop in one of those, and that will open up this desired speed decision window. Or you can also just right-click on the link itself and then go to Add New Desired Speed Decision to open up that window as well. And again, this is where you can see the position information. And then down here in the bottom is where you can right-click and add. And this is where you can add those different vehicle classes along with the distribution that you want to use for each of those. So you can come in here and pick that particular distribution you want to use for each of those. One nice tip is that you can highlight all of these, and if you press the space bar, that will open up this window so you can kind of do a multi-edit. So again, if you just kind of highlight everything and press the space bar, that will just allow you to select the same distribution for everything. And then when you have everything set up, you can click OK, and then you'll have your speed decision here where you can kind of move it to the location that you want. And then what's also nice is when you do have these kind of set up and you have your vehicle classes and desired speed distributions in place, if you kind of want to reuse this at other places in the network, you can just copy those and kind of paste them on the other links. So you can right-click and copy, and then you can right-click and paste onto another link. And this just will save you some time when you're adding a bunch of speed decisions in the network. Once you kind of have a few set up, you can just quickly copy and paste them to other links and just add them that way. And then for the reduced speed areas, if I select those, these again will show up as a box since they have a length associated with them. And so for the most part, these are mainly just going to be used for any turning movements in the network. So you'll see a lot of them at intersections where vehicles are going to need to decelerate briefly as they're completing the turn. So again, if we want to add any of these, you can just press Control and right-click and drag to create one of a certain length. And again, that will open up this window here. You can also right-click and then go to Add New Reduced Speed Area, and that will just add one of a default length here. And then again, kind of similar to the desired speed decisions, you can right-click and add to add in the different vehicle classes, and then you can set those desired speed distribution to those values. And typically, we will usually create one for right turns and one for left turns, just so that you can use that quickly for the majority of your turning movements. And then, of course, you can further refine those and fine-tune those within the model itself. And for a lot of these movements, we find that we usually make them about 6.5 feet, just to kind of show like that behavior where the vehicles are going to be decelerating just for a short time while they're on this reduced speed area, and then they'll start to accelerate again kind of once they're midway through that turn, and then continuing on through their journey. And again, just similar to the desired speed decisions, these you can also set up, and then you can also right-click and copy and paste these to other links as well. Just will save you a little bit of time when you're adding in a whole bunch of these to intersections within your network. And with that, that should pretty much cover all of the different kind of base data within Vissim.